Hello friends, welcome to Supreme Education. We are going to learn property of an angle bisector of a triangle. Statement of this theorem is the bisector of an angle of a triangle divides the side opposite to the angle in the ratio of the remaining sides. The first step to prove any theorem is to draw proper diagram. Now here we are to draw one triangle and bisector of any one angle of that triangle. This is our required diagram or required triangle. Rather, this green color triangle is our required triangle. Now in triangle ABC, ray CE is bisector of angle ACB. Means given will be in triangle ABC, bisector of angle C, intersects segment AB in point E. Listen again. In triangle ABC, bisector of angle C intersects segment AB in point E and A dash E dash B. Now ray CE is the bisector of angle ACB. That means measure of angle ACE equal to measure of angle BCE. These two angles are congruent. Next step is to write to prove. For that, read this statement again and carefully. We have to prove the bisector of an angle divides the side opposite to the angle in the ratio of the remaining sides. Now ray CE is the bisector of angle C, and this ray CE divides side AB, which is opposite to angle C, in two parts. These two parts are segment AE and segment EB. Ratio of these two parts will be AE upon EB. Now this ratio, that is AE upon EB, will be equal to the ratio of the remaining sides of the triangle, and the remaining sides are AC and CB, and the ratio of these two sides will be AC upon CB. Means we have to prove AE upon EB equal to AC upon CB. Means our to prove is AE upon EB equal to AC upon CB. To prove this, we'll do one construction. That is, draw a line parallel to ray CE passing through the point B. Draw a line parallel to ray CE and passing through point B, and extend AC so as to intersect it at point D. Means here ray CE is parallel to segment BD. Ray CE is parallel to segment BD and A dash C dash D. Now the next and most important part is to write proof. First I'll explain proof by using diagram, and then we'll see step by step proof which is written. Now look at this triangle ABD. Triangle ABD, or this whole triangle ABD. Can we use basic proportionality theorem in this triangle? Just think. Yes. In triangle ABD, ray CE is parallel to one of the side of this triangle, that is DB. Hence, by using basic proportionality theorem, we'll get AE upon EB equal to AC upon CD. We'll get this statement, that is AE upon EB equal to AC upon CD. AE upon EB equal to AC upon CD by using BPT or basic proportionality theorem. Now observe these two statements. First one is to prove. The second one that we got by using BPT. Can you guess any difference between these two statements? Yes? Guess? Have a look. The left hand side of to prove is AE upon EB, and here also the left hand side is AE upon EB equal to. The numerator is CA, and here also AC is nothing but CA. These numerators are also same, and here denominator is CB, and here denominator is CD. The only difference between these two proof and this statement that we got by using BPT is of denominator, that is BC and CD. Now we have to reach from here to here. And to reach from here to here, we have to prove CD congruent to CB. Now our target is to prove CD congruent to CB. Look at this diagram. We have to prove CD congruent to CB. Means we have to show triangle CDB as an isosceles triangle. And to show CD congruent to CB, we have to show the angles opposite to the sides as congruent. If we can show these two angles congruent, that is angle CDB and angle CBD, then the sides opposite to congruent angles will be obviously congruent. Now the target has changed. Means we have to show angle CDB is congruent to angle CBD. Now we'll start from these two angles, which are denoted by purple dot. Are these two angles congruent? Yes. Yes. These two angles are congruent since ray CE is parallel to DB, which is our construction, and AD is a transversal. Therefore, these two angles forms corresponding angles, and if lines are parallel, then corresponding angles are congruent. Therefore, angle ACE is congruent to angle CDB. That is our statement number 1. Now look at this another pair of angles, which are denoted by brown colored dots. Are these two angles also congruent? Yes, these two angles are also congruent by using our given since ray CE bisects angle ACB. Therefore, these two angles are congruent. That is our statement number 2. Now look at this last pair. That is this one and this one. That is angle ECB and angle CBD. Are these two also congruent? Yes, since ray CE is parallel to DB and take transversal as now CB. Hence, these two angles forms alternate angles. Hence, these two angles are also congruent. That is statement number 3. We'll revise these 3 statements. First angle is congruent to second angle. Reason is corresponding angles. Second angle is congruent to third angle. Reason is given. And third angle is congruent to fourth angle. Reason will be alternate angles. Hence, first and fourth angle will be obviously congruent by using first, second and third statement. Listen again. First angle is congruent to second, corresponding angles. Second angle is congruent to third angle, given, and third angle is congruent to fourth angle, alternate angles. Hence, from these 3 statements, we will get first angle is congruent to fourth angle. Hence, angle CDB is congruent to angle CBD. Now, in triangle CBD, we got here angle CDB congruent to angle CBD. Hence, if two angles are congruent, therefore their opposite sides will be also congruent. That is, side CB is congruent to side CD. Therefore, we can replace CD by CB. CD by CB. Hence, we will get this statement, that is AE upon EB equal to CA upon CB. Now, we'll see proof which is in written form. Ray CE is parallel to ray BD and AD is a transversal. Ray CE is parallel to ray BD and AD is a transversal. Hence, angle ACE is congruent to angle CDB. Angle ACE is congruent to angle CDB. This is our first pair. Reason will be corresponding angles. Statement number 1. Now, taking BC as a transversal, CE is parallel to DB and BC as a transversal, we'll get angle ECB. Angle ECB is congruent to angle CBD. ECB is congruent to CBD, means these two angles are congruent. Reason, alternate angles. Statement number 2. But angle ACE is congruent to angle ECB. Angle ACE is congruent to angle ECB. Reason given. Statement number 3. Hence, from 1, 2 and 3, we'll get angle CBD is congruent to angle CDB. Angle CBD is congruent to angle CDB. Now in triangle CBD, which is red color triangle, side CB is congruent to side CD. CB is congruent to CD. Reason will be sides opposite to congruent angles. If these two angles are congruent, therefore their opposite sides will be congruent. Hence CB is equal to CD. Now in triangle ABD, EC is parallel to BD. Hence AE upon EB equal to AC upon CD. AE upon EB equal to AC upon CD by using basic proportionality theorem. Now we can replace this CD by CB. Therefore we will get the required result, that is AE upon EB equal to CA upon CB or AC upon CB. In this way we have reached our target. This is most important property of this lesson. Happy learning. Thank you.